bit more intense on the terms of materials. I'm actually warming up the water to the correct temperature while I kind of cover where you'll find a lot of the stuff. First of all, you're going to need your CPO data collector that we've used on a bunch of different labs, but we haven't used the thermometer with it yet. You'll find the thermometer in a baggie. It should just be in like the accessories side. It did not come in the actual black kit with it, but it does hook right up. And then when you're on the home screen, just hit meter mode, and as long as it's plugged in, it's going to be measuring in degrees Celsius. So I'm going to be warming up some water. What I would suggest for this lab, you're trying to get it up to about 50 degrees Celsius. I'm not going to do the mental math, but I imagine that's going to be around 100 degrees Fahrenheit. I think that's how it translates. So like hot tub temperature. Won't burn a kid, but we do want to be careful. Your plate is going to be hotter than that in order to get it up. I might have a larger container of water and have it just at the right heat that the water is maintaining at a good 50 degrees. And so that way throughout the day, you just pour out your water for your lesson. You're going to want to have a digital scale. I've got one here. So that way you can measure out. I've already got my ice water measured out to 100 grams. Once this is up to temperature, I'll measure out the same amount of water that's hot into this. So that way I have an equal amount of hot and cold water for the first part of the lab where you mix them. The second part of the lab you need to have metal washers. You should have containers like this in your accessories or just sitting around. I think they're about 10 grams each, so I grabbed 10 of those. I actually have them sitting in some ice water now, so make sure that those guys are at 0 degrees. I'm gonna have to have one more cup, which I can make real quick. Styrofoam cups available, because I can't have the water there, but these will be my washers, and I'm cooling them down to 0 degrees Celsius. So you can have your students help you set up by labeling some of this stuff, but then they can actually do a lot of the actual experiment. I would just be in charge of doing the pouring. Make sure that you're showing off safety, have some good gloves that will handle this. And we got about 10 degrees left, so I'll just crank it up just a little bit to speed up the process. But even if I don't get it up to temperature, we should still be able to see the results. I think that's all the materials that you need for this one. Make sure that you got ice water. I sacrificed a bit of my own there. So let's talk about what the students will observe as I'm approaching the final degrees. The first step is they're going to be mixing the hot water and the cold water. It doesn't matter which way you go. Probably for safety, have the hot water sitting still and pour your cold in. That way we're not moving the hot water as much. And then students will have to measure the temperature. So make sure you have the other 4 data collectors and thermometers set up, so that way students can collect the data when they mix. What they should see with that one, they have equal amounts of cold and hot. One's at 0, one's at 50. By the time they mix and lose a bit of energy, you're gonna be sitting around 25. It should be kind of evenly matched. But then we have the same mass of metal, but that's gonna measure differently when you mix it with the cold water. Which means I need one more cup of cold water for the second half of the experiment. Which means sacrificing more of my own drink. You could definitely have a discussion with your students. Hey, I've poured in this ice water. I'm not gonna measure the temperature with my thermometer. And you can ask your students, why am I not measuring to make sure it's at 0 degrees? And that's a good discussion to have over freezing, melting, and when you have ice water, it's consistent. I always talk to my students about why do ingredients and stuff like that ask you to boil water to cook things. One is that it's hot, but when you boil, you're ensuring that you have a consistent temperature at all times. Okay, let's go ahead and get our hot water thrown in there. I'm going to measure it out. I'm going to go ahead and start getting my thermometer accustomed to the cold water. Bring that down. It moves pretty quick, so you shouldn't have a problem with that. Put on my gloves for safety, and then we'll measure out 100 grams of our hot water. You can see I'm already approaching 0 degrees on my thermometer. This experiment doesn't have to be exact, but I'll be close as possible. So a little bit extra hot water, but it wasn't quite at 50 degrees. I'm measuring just north of 0 degrees on my thermometer. A little bit of stirring brought me down to a good 3. So even though these aren't perfect, we'll go ahead and mix. I've now mixed hot and cold. I should start to see my ice start to melt. If there's still ice, ooh, may want to do this without ice, but we'll see. I've jumped up to 20, but it is coming back down because that ice is melting. Looks like all the ice, besides one little bit, is gone. And sure enough, floating at around 17. So if you measure things out correctly, shouldn't probably have had ice in there. You'll get a good measurement. And we can do the same thing with our cold washers. So here's my cold washers. And we'll mix some more hot water into those. For the second part of the lab, and we'll see what that temperature looks like. So again, 100. So I'll get my thermometer in there. And this will be a good comparison from the last one. If I had to make a hypothesis, I would say the cold washers aren't going to hold as much heat. And yeah, I'm already sitting right up around 50. So it didn't cool it down all that much. And so students will actually collect their data, take these guys off. And so this kind of gets into, I don't think they're going to formally go into specific heat, but that kind of goes into, so 100 grams of metal does not hold as much heat as 100 grams of water, even though they're at the same temperature. So that's what they want to get to, temperature and heat, kind of different. And then it has a bunch of questions. But go in with that mindset. Temperature and heat are different. Just because you have the same mass at the same temperature doesn't mean you have the same amount of total heat, which is like measure of energy in each of the substances. So pretty good lab. It does take a lot of setting up. You saw I scrambled and grabbed a couple more cups. If you have everything laid out beforehand, students will do this just fine. And then just you're in control of the hot plate. You don't want students messing around with the hot plate unless you got upperclassmen. All right, with all that being said, I think that's it for this lab. We're gonna do some similar experimenting with the next one. So I will catch you guys in the next video. Thanks, bye.